Okay, to Alpha, good afternoon. Can you hear me?
Can.
Okay, can you see my presentation?
Can also.
Okay, can also. Thank you very much for your reply. So now it's 1:01 in the afternoon. So I will continue the lesson for today. Yeah. So I think today I will I try to finish chapter 8. Yeah, chapter 8, force and motion. Okay, make sure you can see also my presentation. Right. Okay. So I will continue. Are you ready, class? Can we continue the lesson for today? Can I?
Can.
Okay. Right. Right. So I will continue our last lesson for last week. Okay. The application of concept of air pressure in daily life. Okay. So number one, plunger. So you must identify which area has the highest and lowest air pressure. Okay, giving the action. All right, whether for example the plunger over here, whether you push the plunger downward or you push the plunger upward. Okay, you must try to identify the area that has low pressure, and then which area has the highest pressure, and then what is the effects on the blockage, okay, inside the pipe over here, right? So this I already cover last week. Yeah. And then the second device is McDibert hemisphere. The action is just like the suction cup. If you see, if you watch back my Pdpr recording last week, you can see, right, which area of the device has the lowest air pressure and then the highest air pressure. And then what happened to the McDibert hemisphere, whether it easily can separate the two hemisphere or no. Right. And then number three is the straw, the action of the straw. You must try to identify which area has the lowest air pressure and then which area has the highest air pressure, and then what happened to the water inside the glass or inside the straw when there is a difference in air pressure. Okay. And then the siphoning action, all right, because of the what we call the different in height in both end of the tube, A and B. Okay, so we have what we call and then also the difference in air pressure lah. All right. For example, at the end of the tube A, placed higher than the end of the tube in B. So because of the highest atmospheric pressure at the upper side of the tube, so the water inside the tank will flow down and empty the tank. All right, you must understand this. And then today, the syringe. Okay, this is the action of the syringe. You must also identify which area has the highest air pressure when you push the syringe upward. Okay, and then which area has the lowest air pressure, and then what happened to the liquid inside the beaker here, for example. Okay, so if you push the okay, if you push the piston upward, what happened? If you push the piston upward, so inside the syringe will become low pressure, and then outside the atmospheric pressure outside will become higher. Atmospheric pressure will become higher. So what happened to the liquid? Because of the different pressure, okay, inside the syringe and then outside the syringe. So the atmospheric pressure is higher, so the liquid will be sucked into the syringe. Okay, this is action number one. If you pull the syringe, what happens if you push the syringe downward? Okay, so in opposite lah. Okay, if you push the piston of the syringe downward, the action will become opposite. Okay, the inside of the syringe will become higher pressure, and then the outside become the lower pressure. So what happened to the water or the liquid inside the syringe? The syringe will get out from the what we call get the liquid will exit or get out from the syringe. Okay, you must understand, yeah, the piston over here, just like what we call the plunger, whether you do the pulling action or pushing action, okay, will depend on the action, whether you push it or pull it, okay, uh, will what we call will change the pressure, whether it has lower pressure or higher pressure. Make sure you can identify which has the highest pressure and then which has the lowest pressure by the action of the piston. Okay, class? So this is how the syringe work out. Okay, then the vacuum cleaner. Now, this is another example of application of air pressure in daily life. We are using a vacuum cleaner. Okay, we have the fan over here. The fan will suck all the air inside the container over here. There is a room over here, right? Okay, there is a room. We call it a collecting, maybe just a container for collecting the dust over here. And then, of course, inside here we have filter. If we do not have any filter, then the dust will suck. The fan will suck all the dust inside the container, right? So we have the filter here, and then we have the fan. The function of the fan, the rotation of the fan, actually, will determine whether the area inside the container over here has higher pressure or lower pressure. Okay, so if you switch on the fan, the inside of the container here will be lower pressure, and then it will suck all the dust from outside. Okay, and then the air pressure outside is higher. High atmospheric pressure and then low pressure inside the container. So the when you turn on the fan, the dust will suck into the vacuum cleaner, and then it will trap here. Okay, but based on the what? Based on the rotation of the fan over here. Okay, if the fan rotate what we call in the opposite, what happen, you think, class? If the fan rotate in opposite, maybe there is a short circuit, or maybe the vacuum cleaner is got some problem. The fan rotate in opposite direction. What happen, you think? It will become vacuum cleaner or it will become blower?
Blower.
Yes, it will become blower. Because if you look at the picture of fan blade. If you look at the fan blade over here, so this is example of the typical fan blade. This is the typical of fan blade over here. Yeah, okay, I will take this picture lah. Yeah, for example. Yeah. So it used, because of the fan blade over here, class. Yeah, fan blade has special shape over here. It will what we call distort a bit. Like here, right? It will distort a bit. So the air pressure will go, when the air go through the fan, it will go higher. Okay, it will go higher pressure. Okay, that's why it can flow the fan, right? It can, what we call the airflow will make the what we call the air pressure area lower and higher. Okay, so in this area it has lower pressure, and then in Y area we has the higher pressure because of the spinning fan. Because of the shape of the fan, we suck up all the air from the X to the Y over here. The same mechanism when we use airplane blades, plane not blades, we call it wings, not blade, wings. Same things over here lah. But you will be learning about this, I think, in SPM, in form 4 physics. Okay, so for example, the aeroplane blades, the aeroplane wings, for example, has a distinctive shape like here, because the air above higher pressure, and then the air above have lower pressure. So what happened to the aircraft? The aircraft will lift. There will be a lift. That's why, because of the different air pressure, at the bottom have higher air pressure. The wing at top, the top surface of the wing have the lower air pressure. Why have lower air pressure? Because it need more time to flow around the wing. You can see the wing shape. It need more time. When the air need more time, so the pressure become low, and then the air pressure underneath the wing has higher pressure, because the airflow will move at higher speed than the airflow at the surface or at the top of the wing. So it will create a lift. It will create what we call a lift. It will create lift. But depending on the speed of the airflow lah. That's why aeroplane need what we call a certain velocity, or it needs certain speed, or it needs certain speed, so that it can create lift. Then the aeroplane can fly. The aeroplane can fly because of the difference in air pressure. Okay, class. Okay, never mind. This is out of the topic, but never mind. Just to give you some what we call information. Yeah, right. Okay. Next one. This you can read this for yourself. All right. So next topic is the relationship between the altitude and the atmospheric pressure. You still remember in Form 1? You still remember the Earth? You still remember the Earth atmosphere? What happened when the altitude is higher? What happened to the atmospheric pressure? What happened to the air pressure? Still remember? I think chapter 9. I think topic chapter 9 in Form 1. Chapter 9 is Earth. There is what we call a relationship between the altitude and the atmospheric pressure, or the air pressure. Okay. If the altitude is higher, what happened to the atmospheric pressure, class? Anybody? Who can give me any idea?
Is
What
it
is
lower?
again? Okay, sorry, class. Again. If altitude is higher, if altitude increase, pressure, atmospheric pressure is increase or decrease? Form 1, you already learned this, if you still remember. What is altitude? Altitude is the height, right? The height of the atmosphere. Okay. For example, 0 kilometer to 13 kilometer above the surface of the Earth. We call it troposphere. Do you remember troposphere? So this is what we call altitude, the height from the surface of the Earth until up in the atmosphere. Troposphere, troposphere. Okay, so never mind. You just remember, okay, class. You just remember, okay, by looking at the picture over here, yeah. You just remember like this, right? If the altitude is increased, so the air pressure will decrease. Just remember that. Again, yeah. If the altitude is increased, so what happened to the pressure? The pressure is decreased. Air pressure or atmospheric pressure will decrease. Okay, why? Because as you go higher, for example, up in the mountain, can you see what is the difference here? You can see that the air particle inside, the air particle when you go higher, the air particle is become the what we call the air particle is become less. The air particle become less. Okay, when you are what we call a lower altitude, we have higher pressure because we can see that the air particle when you are in the lower altitude is much it is more. Okay, can you see the particle here? When you go up, when you go higher, the altitude is higher. For example, you're up in the mountain, low pressure because the particle of the air is less. And then lower altitude, okay, lower altitude, maybe at the foot of the mountain, we have higher pressure because the quantity of the particle is more. Okay, more air molecule. And then up in the mountain or higher altitude, we have less air molecule. Air molecule or particle same lah. Can you understand this, class? Is it okay?
Yes.
Okay, very
Yes.
good. All right. So we are accustomed to, we already get used at which area? Class, I just want to ask you simple question. We already get used. Okay, class, wait. We already get used with the air temperature in which location? Is it A or B?
A.
Yes, A. Because we always at the what we call at the surface of the earth, right? We live and then we born and then we work, we study, and then our body is already get used to the air pressure at the what we call surface of the earth. Okay, what happened? Anybody can tell me what happened if you climb higher and higher? What happened to our body, especially our ear? What happened to our ear, you think?
Like something stuck the ear.
Yes, of course. Very good. Yes. You can feel something stuck there, right? And then maybe you will feel some pain, because our body, if you still remember, inside outside of the ear and then inside of the ear, they try to adjust the air pressure. They try to adjust the air pressure inside the body and then outside the body. That's why when you go higher, okay, you will feel some pain. You feel some pain or discomfort inside the ear because of the ear will try to adjust the higher pressure and the lower pressure outside. Okay. Not maybe just maybe just a few hundred meter also we can feel the ear become what we call become uncomfortable. Okay, because our body try to adjust the lower pressure outside and the higher pressure outside. If you at A location, yeah, if you at the first location A over here, the pressure is equal. Outside same pressure, inside our body also same pressure. But when you go higher, it will try to equalize the pressure. Then you will feel uncomfortable inside your ear. All right? Can you understand this? Yeah. Can Okay. Next one. Okay. Last topic for today. I will just want to what we call finish for today. Chapter 8. Effects of depth on the liquid pressure. Our previous topic is the altitude. Altitude meaning the the height from the surface of the earth until up at the atmosphere. That is the altitude. Okay, how about the depth? The depth is because inside the water, from the surface of the ocean, from the surface of the water, inside the water. So we call it the depth. DEPTH. You still remember also in Form 1, you already learned about the zone, the ocean zone, surface zone, and then midnight zone, and then the dark zone. Is it two? Never mind. Okay. All right. Opposite with the altitude of the altitude and the air pressure, what happened here? What happened here, you think? So, according to the picture over here, I just use the picture over here. So, let's say that this is the surface of the water here. This is the surface of the water, class. All right. This is, can you see the surface of the water? I am drawing the surface of water, right, class? Can you see it?
Yes.
Okay. And then this is the depth. D, E, P, T, H. And then the depth, they measure in meter lah. Okay. Maybe I just draw it roughly on only. Maybe this is I just draw it roughly. So maybe this is 5 meter, and then 10, 15, and then this is 20, and then this is 25. This is the depth in meter. Okay. So which area has the highest liquid pressure? We are talking about liquid pressure, not air pressure. Okay. Which area do you think has the highest liquid pressure? Is it in A or is it in B?
B.
Okay, of course. So, very good. Okay, correct. Your answer is correct. So, as you go deeper into the liquid, so the pressure of the liquid become higher. Okay, so you can say that if the depth increase, what happened to the pressure? If the depth increase, what happened to the pressure? The pressure also decrease or increase?
Increase.
Okay, the pressure also increase. But what type of pressure is this? This is the liquid pressure. Okay, if inside the water. But air, inside the air, if the altitude increase, what happened to the pressure?
Decrease.
Decrease. Very good. So what type of pressure? Air pressure. This is for atmosphere. Okay, this is for atmosphere, and then this is for liquid. Okay, this is for liquid. Okay, class, you have any question? Can you understand this?
Yes.
Okay, very good. You still remember the watch? The wrist watch that has the right 30 ATM, 30 ATM, 10 ATM. Meaning that the watch can withstand that kind of pressure. 30 atm is a lot of pressure. They call it a diver watch. You can see, you can watch back my previous video recording, right, about the watch. Okay, next one. Okay, effect depth on the liquid of pressure, I think you already know lah. Low pressure at the surface of the water and then higher pressure. That's why when you try to build a dam, you need to build a thicker wall at the bottom and then thinner wall at the upper, because higher pressure need thicker wall. Okay, and then at the upper side of the dam, you have just built a thin wall, can withstand the low pressure at the top of the water, at the surface of the water. But inside, the more depth you go, you need to have more what we call support. You need to build a thick wall. Okay, right. Submarine, for example, the diver need to wear a special harness. Okay, I want to show you one picture over here. Yeah, deep dive suit. See this? There are special what we call suit in order to diver. They need to wear a special suit, depending on the depth of the water it want to dive. Okay, for example, this is very special suit. The diver can go very deep. I don't know how many meter it can go down, but you can Google it yourself. And then B is the maybe intermediate lah, the medium depth. And then for suit in C, maybe just about not too deep lah. They can dive inside the water with a very shallow, what we call shallow depth. Okay, so these are the what we call the suitable suit for diver in order for them to withstand the liquid pressure, because as you go deeper, the pressure is higher, and then maybe it can kill you. If you go deeper without any protection, it can kill you. Okay, because you must remember, our lung inside is filled with what? Lung filled with what? Air or liquid? Inside the lung. Inside the lung we have cavity, right? We have air or liquid inside the lung?
Liquid.
Inside our lung, liquid or air?
Air.
Because inside our lung are filled with air. Okay, if you go down deep in the ocean, in the water, the pressure, the higher as you go deeper, the liquid pressure will try to crush our lung. That's why you need to wear a special suit, right? Which is much density? Which is higher density? Is it liquid or air? Guess, as higher density. Liquid or air? Of course, liquid, right? Okay, I hope you understand, yeah? Right. Okay. So, okay. So I think I will finish here. Do you have any question to ask, class?
No.
Okay. If there is no question, tomorrow we have class. I think tomorrow I will just give you some relief lah, yeah? But never mind. I will try to give you exercise after the class. Tomorrow we have 3 period. Never mind. I will think about it whether we want to have online class or not tomorrow, because we just finished chapter 8, and then I need you to focus, try to finish all the exercises on chapter 8. Okay? So I will give you the decision letter whether I want to do the online class or not for tomorrow. Okay, class? So can we stop the class here? Can we end the class here, class? Okay,
Sure.
Okay, so thank you very much for your participation. You can leave the class now. Bye-bye.
Thank
Thank
you,
you.
teacher.
Thank you.
Thank you, teacher.
Thank you very much, Wisha.